Okay, we're at the top of the hour. Let's go ahead and get started. Let me start by introducing myself. My name is Ryan Schmierer, Vice President of Operations for Sparx Services North America. And I'd like to welcome you all to our first in a four-part webinar series on the journey to model consistency from model validation to model governance. This presentation today will be talking about how do you author success and setting the foundation for what model quality is all about. I'm joined today by our two speakers, Dr. Istvan Rath, Managing Director of IncQuery Group. Welcome, Istvan. And Chris Armstrong,
Hi,
President and Chief Architect of Armstrong Process Group, who is also involved with our Sparx Services North America organization. So Chris, welcome.
Thanks so much. Great to be here.
And let me hand it over to you guys to go ahead and get us started on the presentation. As we get started, there is both a Q&A and a chat feature here within the Zoom platform. If you do have questions, please go ahead and log them in either one of those two sessions, and we will have time for Q&A at the end of the presentation. Istvan, over to you.
Yeah, thank you very much, Ryan, and thanks again for the introduction. Welcome, everyone. Thanks for taking the time to join our webinar today. And just to set it off, I will start with a little bit of an introduction to IncQuery, and then I will hand it over to Chris. So basically, IncQuery is all about creating digital engineering success. We've been working for many years in the industries, aerospace, defense, mobility, biomedical devices, and many others. Basically helping our customers with MBSE. Complexity challenges around that, designing processes and tool chains, increasing productivity, closing productivity gaps, and of course, developing quality assurance solutions, which will be the topic of today's presentation. And now, Chris, the floor is yours.
All right, thanks, Istvan. So just a little bit about APG. Our whole reason for being here is to really help end user organizations adopt industry standard best practices and deliver world-class outcomes. Play a lot in the enterprise architecture and systems engineering fields, and a part of that mission is to participate in the contribution of industry standards, including ones that are relevant to some of the things we'll be talking about today, particularly UML, SysML, and UAF at the OMG, but we've also participated in enterprise architecture initiatives at the Open Group, namely TOGAF and Archimate, and the IT for IT reference architectures, as well as being involved in a number of key work groups at IncQuery. And as Ryan said, we're also the operator for the Sparx Services franchise here in North America. So, I'll kind of, start off, setting the stage for, why we think we need, some kind of model validation support. And then Istvan's going to take over a little bit later and get a little bit more, show you guys a little bit more about the solution and the validator that IncQuery's created. So, let's, take a step back and, what is model quality and what are some of the different dimensions? Namely, we think that there's, three different areas we need to be mindful about. Just the casual mistakes that people can accidentally make when they're building a model. As many people may know, if you guys are users of Enterprise Architect, which I presume you probably are, which is why you're here in this webinar, is that Enterprise Architect, on the one hand, is a permissive modeling tool in the sense that it allows you to, build models using many different languages, and, exactly how you use them is really left to the end user. So that's both a good thing, because it gives you a lot of that flexibility, but it also can be a liability as it relates to making sure that you fill out all the right properties of your elements and relationships and the diagrams that you build. There is a point where you do need to be concerned about that. There's also the tailoring of how you're using the tool and the modeling languages to support a particular methodology. Whether that's the SysMod methodology, OOSM, your own homegrown architecture or engineering or development process. And then, of course, there also comes a point when you need to be concerned about, how conformant and compliant are we with the different semantics and syntax of these various languages. And so the idea behind this, of course, is that, having consistency across the projects that we build, particularly in a large enterprise where we have a lot of different teams, is important. So kind of like in development, where we like to have coding standards where you can't really see and understand who built different pieces of code based on the style. We want all those models to look, have at least some familiarity and regularity. We also, I think, understand from practice, and of course, this has been brought up by empirical studies, that, if we discover issues earlier on in the process, that tends to be something that has a downstream effect of being more expensive and more risky. So the earlier we can find issues, the better. We also, if we have the ability to give people real-time feedback to, how well they're, again, avoiding these common mistakes, conforming to our adopted methodology and the standards that we're using, can really help provide good feedback to modelers that are building this content, so they can get, better. Because, certainly it wouldn't be an aspiration that we could build, error-free models at some point. But as many of you guys know, because of the complexity of these languages and the nuances, it's really tough for that to be a first-class goal. But any way that we can, again, inform people about, hey, you shouldn't be, you should fill in this property, you need to draw this type of connector between these types of elements, is going to improve the performance and maturity of the modeling team. And so, today's, we're going to be focusing, again, we're going to kind of be spreading this over a series of 4 webinars, as Ryan said at the beginning. So we're going to start off with some of the quote unquote simple stuff. What does it mean? What do we mean by common mistakes? So an example one, is shown here, as you might guess from the frame, as well as being familiar with the SysML or UML and Enterprise Architect. This is a very simple state machine. And so here we just have a situation where there are transitions between nodes that don't follow the rules. So for example, the one on the left that's highlighted in red, that's a case where an outbound transition from a choice pseudo state, does not have a guard, and that is required because, of course, in interpreting this, visually by looking at it, you go to the choice, and there's supposed to be a guard on all outbound transitions, so that when we're, possibly executing this, simulating this, or of course people are using this for specifications for testing, that it's clear exactly what conditions trigger us going left, right, forward, or backwards. And this, again, might appear to be an innocuous, simple, certainly simple kind of error, but this could have, non-trivial downstream consequences, namely, as different people, particularly downstream consumers, look at this model, they might not know what that means. Does that mean that there isn't a condition? You forgot the condition? Exactly how are we supposed to interpret it? And then as people start then building solutions based on these models, there may be unintended side effects that are introduced because of that ambiguity. And in certain cases, depending on what the subsystem or component is, there could be a potential, non-trivial cybersecurity issue in the product that we end up delivering. And these are just a couple of examples of a set of rules that have been put together by the SAIC organization. That's a part of their digital engineering validation tool set, which the IncQuery product has an out-of-the-box implementation for. And so, where do these errors come from? Well, part of it is a lack of expertise. So, of course, people that are, beginning their voyage into more formal modeling, particularly around MBSE, model-based systems engineering, but also for, enterprise architecture and software development. The tools and the languages have a lot of features and capabilities, but it's not always clear to people that are new to it which are the important ones. It's real easy to focus on a certain perspective and accidentally or unintentionally ignore another. So again, unfamiliarity with the tool and the language is a contributor for this at the beginning. There's also a lack of attention, and I don't mean that pejoratively in the sense that people don't care and aren't paying attention. But modeling is a means to an end, an important one, of course, for engineering and architecture. But we all understand the pressures that we're under on a day-to-day basis, to get things done, the deadlines we have to hit. Other factors going on with our organization, and it's real easy to unintentionally not notice that, oh, I forgot to do this, or I should have done that, so on and so forth. And then there are, again, the invisible, or what we're calling quote unquote invisible errors. And so one of the challenges, of course, is that as a part of making the transition from using drawing tools like Visio, for example, or Draw.io or PowerPoint or whatever, we have a tendency to create a small number of large diagrams that have everything on them, because that's all you get, is the diagrams that are produced by those drawing tools. And many of you guys may know that, one of the things we want to think about, particularly in an agile modeling approach, is instead of creating that small number of large, complicated things, we actually want to do the opposite. We want to create a large number of small, focused, targeted things. And one of the consequences of that is that, again, as we're transitioning from a drawing tool to a modeling tool, is that information about a single thing in our repository might be spread out over 4, 5, or 6 diagrams. So you never are necessarily going to see everything about a particular element or connector on any given diagram. And then there are numerous properties for different things in SysML in particular that don't necessarily have graphical syntactical representations, but they are important semantical properties that you can specify in Enterprise Architect. As you may know, that would often be done in the property sheet. And so, relying on, visual inspection of diagrams and model content is just not sustainable. There's a lot of content. There's ambiguity about who should be responsible for that. It's really something that we want to make a team responsibility, not an individual contributor. And we also have the challenge that, all diagrams are liars. And what I mean by that is that, again, what you see on any given diagram is only what the author of the diagram felt was important to put on that particular diagram. So, and again, the complexity of the languages, everything going on in our worlds, make it really tough for us to stay on top of this as humans. So, Istvan?
Yes, thank you very much, Chris. The question is, of course, these are rather high impact issues in the end, if you all consider just the example that we have shown today. So how can we address that challenge? How can we help here? And of course, the main topic of today's webinar presentation is a new product from IncQuery called the IncQuery Validator. It's basically a tool that is designed specifically to address these challenges. So essentially identifying errors in enterprise architect projects, and also doing it in a way that is really intuitive, so easy for the user to use and understand, and of course get value out of that. So not just to identify errors, but to fix them. Essentially realizing the end-to-end interpretation of this quality assurance workflow. The concept that is basically at the heart of the tool is what we call model governance. So model governance, in essence, means an approach or a practice that can be adopted as part of your MBSE process to make sure that all the 3 main pillars of model quality are addressed in a systematic and reproducible way. So namely, all the work that is done, especially in the collaborative context, is consistent in style in terms of standard conformance, for example, universally understandable across several teams in terms of being consistent with a methodology, either a standard methodology or an in-house methodology. And of course, fundamentally also free of common mistakes and anti-patterns, which are rather easy to make because of the factors that Chris has mentioned before. And of course, the tool can also be used to assess the completeness aspect, not only from a quality point of view, but also from the point of view of whether there are missing things which should be there in terms of what the methodology describes. In case you want to know more about these principles and how it's all constructed, there is a pretty comprehensive white paper available on the Sparx community website. I put the URL on the slide here below, but we will be circulating this afterwards, so you can easily look it up yourself. So I think that's more than enough for the slides for today. And now I'm going to give you a little bit of a practical glimpse into how the tool actually looks like. So how do we use it? But of course, this will be very short as we have rather limited time today. So let me just refocus the screen share on my other window here. So here in this particular setup, I already have Enterprise Architect running, open with a SysML sample project. This is actually similar to what a real-world systems design project would look like, but of course a little bit stripped down for demonstration purposes. And here you can already see how the validator looks like when it's deployed as an add-on to Enterprise Architect. So it contributes a specific view, this validation results view, to the user interface of Enterprise Architect, which already gives you kind of an idea how this looks like. It's basically already contains some results because I have run the validation already in preparation for this demonstration session. It's essentially a really long list of the findings that the validator has found in the previous run. By a finding, what we mean is essentially something that you have to address as an engineer. So there are 4 categories: fatal errors, warnings, and infos. And we can, for the sake of this demonstration today, switch off the last 3 and just focus on the fatal errors. And these are basically coming from this SAIC digital engineering validation rule set that Chris has already mentioned in his presentation. So, for example, if I, as a systems engineer, I want to do something about these findings and fix one of them, one thing I can do is just to double click on such a finding. And what the tool will do is it will adjust my focus, open up the corresponding element both on the left side in the tree and also if it's shown on a diagram, on this diagram representation as well, and add the red highlight to draw my attention to what is essentially the problem. This demonstration project is of course a little bit prepared, so there are some annotations built in the diagrams to indicate what is the issue. But if I don't have that, what I can instead do is I can also click on Open Rule Description, which will open up a browser window. And this browser will be directed directly into our knowledge base, which comes built in with the tool. So basically, all the users have access to this. And in the knowledge base, there are really useful articles for each of the rules that are supported by the tool that describe what is really the problem here, give a little bit of a context, what exactly the finding means, why it has been found. There are some built-in examples as well that help you understand what the problem is. And most importantly, down here at the bottom, there are some solution strategies included in the documentation as well, basically giving us a hint what to do in order to fix that particular error. So in this case, this state has no incoming transition, which means that that is probably a reachability issue here. So just to fix that, what I can do is very quickly add something like this here, and also fix the error by making sure that there is now an incoming transition. And if I want to see the effect of the work that I have done, I just quickly go ahead and save it, and I rerun the validation. This is done after a brief initialization phase in the background. So you will see shortly that this progress bar is going to come down into the validation results view. And while that is running in the background, I am totally free to continue working on the model, so I can explore further diagrams or make some changes or look at the properties view and so on and so forth. So basically, it's a background process. This is not a small model, but still the validation runs relatively quickly in the background. So if I get back to here, I should be able to see very quickly what the end result was. If you paid attention, you may have seen that previously there were 11 fatal errors in this view, and now there are only just 10, mostly because I fixed that error. So this is how I can see and get instant feedback in terms of quality on my work. What is really the effect of what I had done? How did I eliminate a little bit of the technical debt which was accumulated in the work? Mentioning technical depth, there is another really useful feature embedded in this standalone version of the validator, which is called the statistics view. So the statistics view really is focusing on how to visualize and make sense of the technical depth and where that is centered in the project. So this view can be ordered by this findings metric. And the findings metric is actually comprised of two numbers and the percentage. The first number is really the number of findings that belong to a particular rule. And the other number is what we call the applicability scope. So how many potential contexts the project or my model contains where the rule has some meaning. And of course, the higher this number is, that is an indication of a really significant problem area, because that tells me that out of this applicability scope, a lot of these are actually hitting findings. So I have a lot of work to do in terms of quality. So for example, one area that might be of interest to me is the state name. This is actually an error. As you can see, it's related to the completeness aspect of the model governance. So if I want to take a look at those issues and resolve some of that problems, I can go to show findings, and then basically all of these findings will be here in my view. I can focus on them, and of course these are all states that do not have a name. So for example, again in this case, I can just go open rule description. I can take a look at a similar description in this case, and also the resolution strategy will tell me that I will need to add the name to get rid of that particular message. Okay, so much about the live demo, and now I will go back to the presentation. Yes, so what you have seen just now in this short demonstration session is what we call the standalone variation of this tool. But as you can see, there are actually two more flavors available of this technology. So aside from the standalone, which is an add-on to EA 15 and 16, we have a team tier available as well. That is actually a standalone application that can run completely independently of Enterprise Architect, either as part of your workstation configuration or a regular toolchain. But what is much more interesting is that it can also be deployed in an automation pipeline style deployment. So it can run automatically in the background attached to your collaboration platform, either with SQL or Git, and it can basically run the same set of quality related configurations and generate reports out of that, which are HTML documents that can be navigated and used in a browser. And finally, we also have an enterprise variation of the product, which can do basically the same thing, but at scale. So work with really large repositories, work with a really large number of models, and produce thousands of reports, for example, overnight to cater to the needs of a really large and complex organization. These results can also be then integrated with Excel-based reporting solutions to really get interesting insights out of that. So to conclude, what we have learned today is that, of course, the consistency of models within and across projects is really, really important. It's a prime, it has got a very strong and prime impact on the overall success and outcome of MBSE processes. The earlier we can discover and resolve errors, the more costs we can save. And of course, the better we are at managing risks in these projects. Unfortunately, because of various reasons, visual inspection of diagrams and models is not really a sustainable approach. So instead of tackling this complexity and difficulty of SysML modeling construct, what you can do is take advantage of this new product that can help informing all the members of the team of model quality issues in real time for the purpose of maturing MBSE implementations inside your organization. So with that, I would like to say thank you very much for everyone for attending. And now I guess is the time to answer some questions.
I'd like to start by welcoming everyone to the second in our webinar series on model validation and model governance. This session here is focused as a deep dive into the model governance topic.
All right, so like before, we're going to kind of follow a similar format. So we'll talk a little bit about, some of the challenges. For those of you that joined us before, again, we'll find this slide familiar that, we're really talking about model quality and it having a couple of different dimensions, free from common mistakes, which is what we handled last time. What we're going to talk about this time is methodology conformance and standards compliance. And so just a little bit about that, namely, there's, the standards that we have chosen to adopt, which might include some of the things you see on the left, SysML, UAF, Archimate, or possibly a combination of all those things. But also including things like, there are communities within the NATO architecture framework area that are using Archimate instead of UAF. There's extensions to SysML like SysFis for platform independent modeling related to simulation with Modelica and MATLAB, or RAML, the risk analysis and assessment modeling language, again, delivered as profiles to the base SysML. So, we're talking about, how well are we following those standards as it relates to the rules that they specify about how to construct well-formed models. And then methodology conformance is, A, presumes that you do have a method that you have adopted. That is one thing that we often help organizations with, which is, as you may know, all of these modeling languages are simply specifications for how to represent the semantics based on or syntax based on a set of semantics, but they do not include how you're supposed to use them. So that's a method question. So assuming you've got a method, might be based on, ISO 15288. It could be an out-of-the-box MBSE method like SysMod or OOSEM, or if you're doing enterprise architecture, you might be doing TOGAF or following some of the guidance in the UAF style guide. But in addition to taking, those out-of-the-box methods, you also may be making changes for your organization or have different tailorings of those methods for different types of projects. So let's take a quick look at some simple examples of what we mean by standard compliance and method conformance. And so the first one being a simple example that, as some may know, according to SysML 1.6, section 93213, and particularly constraint number 2, it states that proxy ports must be typed by an interface block. And what the validator has found is a port on a part in an IBD that is specified as a proxy port, but the element that's been assigned to it, which we put on the diagram for convenience, is not an interface block. It's a normal block. So, it could have been something that was an accident. The correct answer is it's supposed to be the power interface block, or the other option is that you forgot to assign any classifier to that port. But the whole idea is that, as we're, building these models, we're, hopeful that we're following the SysML specification, we're doing it correctly. But with these types of, inconsistencies, we may find that these models might be incompatible with other modeling tools, or tools that are in the further downstream tool chain, including, simulation tools, and that this error might cause those simulations to fail, or other downstream tools may report errors. So it's obviously in our best interest to try to identify these things early so we can avoid having to do additional rework later in the life cycle, which can result in missed deadlines and then also lead to increased costs as it relates to our budget. And then an example of methodology conformance. Oh, there we go. All right, thanks, Istvan. This one is related to missing traceability relationships. So while not necessarily explicitly specified in SysML, where it says that a use case, can have a number of different relationships to other kinds of things, our method may say, for example, as it's shown here, each use case element must have a refine or trace element to a requirement element. And again, there's all sorts of reasons why that might need to be a rule, particularly as it relates to quality controls and certain safety certifications. But we've not followed our rules based on our adopted MBSE method. That's noticed here by a missing traceability link. And of course, the challenge with a modeling tool is that, well, certainly, on a use case diagram like this, you might not expect to see a refine or a trace relationship. But that doesn't mean there shouldn't be one in the repository. It may or may not be displayed on another diagram or in a relationship matrix in Enterprise Architect. So again, another example of you just can't rely on visual inspection as the sole way of reconciling these issues. But that may result in a safety-related concern related to ISO 26262, which then, if not caught, could result in some detrimental audit finding in your certification process, which is usually really bad for a lot of organizations, which again can result in the same kind of consequences as issues with standards compliance.
Okay, thank you very much, Chris. Now it's my turn. Question is, of course, after realizing all of these issues that can happen, what can we do to address all of this? Before we get to that, I just wanted to add a little bit more context to one aspect of all of these topics, which I think is very important from a practical point of view. Namely, where does this quality question really come into play when you think about this in terms of the maturity of the MBSE practice in your organization? Now, this illustration table that you see here on the slide is something that we quite often use to really illustrate and also discuss with our customers in terms of where they are in their MBSE adoption journey and how we can help them. So majority of organizations obviously start with a document-based workflow, and once they start using and adopting MBSE tools like Enterprise Architect in particular in a small group of people, that's when they get to the first stage that we call the silo stage, where still it's an isolated use of MBSE. But once you get to this source of truth level, which is then intends to say that you start taking more value out of MBSE tools and Enterprise Architect in particular, not just using it as an illustration or some kind of a additional practice related to documentation efforts, but really also want to make sure that whatever engineering information gets captured in the MBSE tool or the architecture modeling tool is really valuable and can be integrated in other engineering workflows downstream. Simulation has been mentioned in the example before, or any kind of safety security, variant modeling, or essentially integrating with PLM or other documentation management platforms. This is the point where you really need to make sure that the value that is exercised with MBSE is maximized by really paying a high and elevated attention to quality issues. So to make this a lot easier also for users of the Enterprise Architect world, we have developed this new product, this IncQuery Validator, which we have covered in the webinar before. So you may remember in simplest form, it comes as an add-on Sparx PA that provides lightning fast and powerful model validation capabilities, but it also targets collaboration scenarios as well. So what do we mean by the implementation of this model governance aspect? In simple terms, essentially automated solutions to address consistency issues. So make sure that all the models are consistent in style, conforming to the standards and languages, as Chris has described before, universally understandable across several collaborating teams. So once the organization gets bigger and several groups of people start to work together on related projects, this is where methodology conformance, like, for example, making sure that the traceability links are consistently applied, is a very important aspect. And of course, also free from common mistakes, which we have covered in the previous webinar. So as you can see on the screenshot, the validator does not only provide built-in interface capabilities as part of the Sparx EA environment, but it can also produce reports and documents which can be interpreted and shared independently of Enterprise Architect. And this is one of the things I want to show you in a demo. So let me just switch over to my environment here. Yes, here in this example, I have opened up the same example that we have used in the previous webinar. So this is essentially Enterprise Architect, and IncQuery Validator is integrating into this environment, providing this validation results window. And this is the main user interface that you can interact with the functionality of the system. Here in this particular example, I have asked the validator already to run this SAIC digital engineering validation toolset, which we have covered in the previous webinar. That's a basic but quite impactful and powerful so-called governance framework that provides a lot of these rule definitions that can be applied in the SysML context. So once you run the validator against your model, you get a lot of results in this validation view, basically categorized into 4 severity categories: info, warning, error, and fatal errors. It's quite easy to filter out the ones that maybe are not so important for the particular workflow that you are focusing on. And here we already have this example right here as part of this central project that Chris has highlighted in his presentation, this proxy port not being tied by interface book. In fact, we have 2 examples of such a violation. So this user interaction that you can see as I'm doing in my demo is basically a double click on each of these findings, as we call them, that will navigate you directly to the affected element, both in the browser, tree on the left, and also on the diagram, if that's applicable on the right. There are several visualizations of an element in a diagram that Enterprise Architect will ask you which is the one that you are interested to see. Of course, if you are not immediately clear with what this error message is about, it's very easy to navigate to the rule description, which opens up a browser window and it pops you right into our knowledge base. So this is a knowledge base that we provide access to all of our users. And here, for each of the rules that are part of the currently open configuration, there is a built-in documentation available, which gives you a description of what the rule is checking for. So this is the proxy port example that we have seen before. And we have some violating and non-violating examples for this. And also at the bottom, basically a simple recommendation how to get rid of or how to resolve that issue. You have the same kind of functionality for all of the rules. So if you this one works very similarly, but it will navigate to a different kind of issue and so on and so forth. So this is pretty self-explanatory part of the documentation itself. There is another way of working with this view, which is the statistics mode. This is something that I have also shown the last time, but maybe this time we get into a little bit more detail. So in the statistics mode, the visualization is a little bit different, because here it's very easy to create a kind of a burn down chart of all the violations that have been found by the validator. And if you order by this finding column, then you can very easily navigate or isolate the rule that is contributing to the majority of the the technical depth or the set of findings that have been identified in your project. In this particular case, this is this pin rule. So this is 118 findings in the model out of 178 possible findings. So in order to understand a little bit better what the validator means by these possible findings, we can again navigate to the rule description. So this particular rule is about activity diagram integrity. So these are pins which are owned by call operations and they do not have the sync element. So there is some kind of a potential problem with the object flow here. So essentially, you can see in the documentation of the rule that there is a category called scope elements, and this will be an important concept to understand that number that you have seen in the previous one, because essentially this defines all the set of model elements in the project to which the rule will be applied to, right? So essentially, call operation action and action pin pairs where the call operation action owns the action pin. So again, going back to this particular example, this particular project contains 178 such element combinations, and out of those 178, actually 118 have this issue. So this 66% as an indicator gives you an idea that the majority of contexts in which the governance engine has found a problem is affected. So there is this is a pretty significant source of the issues. Of course, this is just a warning, so this is something that you may decide to ignore altogether and just focus on the errors. Again, going back to the traditional list view, like I said, it's very easy to switch on and off all of these activities, and of course, order by category or rule or descriptions or just the severity of the issues. That's also pretty straightforward. So, like I said, this is the basic built-in functionality. And if you want to share a report or just to communicate what is the overall quality status of your project to another stakeholder, you have the option of exporting or saving the validation rules to an external format. So in this particular case, I will just choose the HTML version for simplicity. And this creates this governance report as a standalone document here in my folder here, which you can open very easily in any kind of a browser. And this document carries pretty much the same information that is also encapsulated into the embedded validator viewer. So you get a high-level overview with the number of overall findings relative to this applicability score. Here on the top, there are, of course, also inapplicable rules that have none of these preconditions met. And further down the report, if you, for example, pick one of the rules that is of interest, like this related to the pins, this will be shown in detail. So all of the detailed findings here are listed. For example, for each of the rules, there is the message also containing which particular element is affected, and also a clickable link that you can click, and then it will navigate back to Enterprise Architect and highlight the particular element, which is now highlighted in the tree on my left. Like I said, this is a completely standalone document, so there are no dependencies to load. You can very easily just put it in an email attachment or share it or even publish it or Confluence or similar systems. And in fact, the tool has an additional capability. So for example, if I just close this project down completely, just hoping that it will in fact open my project properly. Yep, so here it is. Here is my project. You can see that the validation result view is completely empty. So what I can actually do is I can take this file and open it and load it into this view, and it will give me back the same kind of result instantaneously. So there is no need to rerun the validation again. If you just want to take a look at such a document inside the Enterprise Architect environment, you can do pretty much the same things. For example, the proxy port type works as before. So what else does this document include? Here you can see that there is a high-level key performance indicator that is, let's say, the highest kind of a compacted summary of the quality status of your work. This is following the regular, scale that we know from the school, from A to E. Essentially, you get an E if you have fatal problems in your project. In this case, you do get an E because of the fact that there are 9 rules altogether that have such issues like the activity, ownership, and things like that. So that's the reason why we have such a low score. But if you do not have fatal errors in your work, just errors or warnings or infos, then you get an improved score, B, C, B, and A. Of course, A is for situations when there are no warnings at all. So it's fully free of issues and further down the scale. And this is, of course, a very useful, let's say, quick metric, because just by looking at this, you get instantaneous an idea. Do I need to do some work in terms of, taking a look at individual findings, or am I okay to continue my work as before? And this is especially important when you work on the project as part of a longer process or with some collaborators. What you will be, of course, aiming for is getting as high a quality score as possible, or keeping a high quality score as possible all through the iterations as you add more and more content to your model, or enhance the content of the project. This quality score can be also recorded if you organize a little bit more elaborate collaborative infrastructure with the help of the validator. This will be a topic that we'll be coming back to as part of a later installment in our webinar series, how to organize and automate this governance practice, especially in the situation where there are multiple collaborating parties working on the same model. The final feature I wanted to share with you is just to provide a little bit of a glimpse as to how the other export format looks like. So I'm also going to save that here very quickly. Yeah, you should not try things like this with a Mac, but I will. Yeah. So of course in Notepad it's not very nice to see, but basically this is a technical document. It's a JavaScript formatted technical document that contains everything, every bit of information which is rendered normally as part of this HTML document that I was showing to you. So this is the key to integrating additional environments for data analytics purposes or documentation purposes, or even rendering it using a custom template as a Confluence page. These are basically just some examples of the case studies or solutions that we have built on top of this technology. So this enables to handle or elevate the quality related or the governance related metadata that is calculated and generated by the validator into more sophisticated workflows, which we'll be covering in part of the webinar series. So this concludes the short demo, and let me just share or switch back to the slides again for concluding the webinar session for today. So with this, I would really like to thank you again for joining us for this webinar. And I encourage everyone to reach out to us, go to this URL, which is shown on the bottom here, just fill in the form and let's get in touch so that we can help you evaluate and try the technology with the hope that it will bring significant benefits to your MBSE practice.
Great. Well, welcome everyone. My name is Ryan Schmierer. I'm the head of operations for Sparx Services North America, and I'd like to welcome everyone to today's webinar. This is part 3 of a 4-part webinar on the journey to consistency within your architecture models, getting through the journey from model validation to model governance so you can really control what's going on within your architecture models. Today, our webinar is going to be focused on rules, rule sets, and profiles. So what we're talking about here is how do you write custom rules to validate your models against the things that you care about. And there's some different pieces involved with that puzzle that we'll be talking about today.
So just to kind of kick it off, this is, again, our third webinar. We can provide links to the preceding webinars if you haven't had the opportunity to join us for those to get to the recordings. But, we've gone through, some of the different dimensions of what do we mean by, model quality, and what does validation mean? What is it good for? How does it help us? The idea that, we're trying to help both, modelers from making common mistakes, being conformant with whatever methodology our organization has adopted, as well as the standards that we're supposed to be complying with, such as, SysML, UAF, Archimate, BPMN, so on and so forth. But what we're going to focus on today is it's all well and good to to have this capability with an out-of-the-box set of rules, which is, of course, a great way to start. And, of course, the architect in me is like, well, I certainly don't want to have to redefine a bunch of stuff that's already been defined, that's been vetted and proven and validated. So, what happens when, you start with the methodology conformance with something like SysMod or OOSEM and standards conformance with like SysML, but then you want to implement your own custom methodology, as well as possibly your own custom meta model by implementing in Enterprise Architect what we call a UML profile, and then packaging that in a MDG technology. So that's what we're going to be. Istvan will be taking the reins from here, and we'll share with everybody the features of the product set that allow you to tailor the validation rules and the sets of rules to your specific implementation needs. So why don't you take it from here, Istvan?
Yeah, thank you very much, Chris. As we've been talking about during the last 2 iterations of this webinar series, of course, the topic is our product, IncQuery Validator for Enterprise Architect, which is a quite powerful new product to add model validation capabilities into the Enterprise Architect ecosystem, basically from the built-in add-on capabilities as part of the authoring environment towards DevOps compatible deployment options, which we will actually cover in the last webinar series at the end of August. So the topic for the demonstration today is actually one of the most often asked questions that we get when we talk about the product. It's all nice and good, but how do I customize the functionality? How do I change the way the built-in rule sets behave? How do I add my own rule into the picture? So this is exactly what I'm going to be showing to you today. And of course, the biggest feature of interest here is what we call the Ruleset SDK or software development kit that comes with the validator. And this is actually a standalone tool, as you will see later in the demonstration, that works in tandem with the validator as an add-on inside Enterprise Architect or as part of a DevOps style deployment. The aim of this feature is, of course, to help advanced users, so systems engineer or modeling experts, really to fine-tune the validation capabilities, basically for the aim of perfectly fitting in-house methodologies or best practices. Now, this, I have to underline again, is of course something that is meant for advanced users, so people who are not afraid to use a kind of a software engineering environment, which Eclipse fundamentally is. But to make that easier, we not only provide the SDK itself, but it comes with a lot of tutorials, built-in samples. You can also get the original specification sources of the built-in rule sets, which we have covered in previous iterations of the webinars, of the SAIC or the sysmod rule set, and so on and so forth. And of course, if you are really into this, then we can also help you with trainings and further customization options, which can boost your capabilities even further. But let's not get so far ahead of ourselves and just cover the basics as part of a couple of demonstrations for today. First off, I will actually not start yet with the Eclipse-based environment, but something a lot simpler, because I consider this aspect of the customization of the abilities of the validator the most fundamental way to do this, which is actually related to a feature that I have been showing in the last webinar, what we call the structural validation or the MDG validation. Now, I suppose most of you are familiar with what MDG technology is. It's basically the feature set or built-in capability of enterprise architect to capture profiles. Actually, the well-known domains like SysML or BPMN or others come as built-in MDGs in Enterprise Architect, and you can also create your own if you like. So a lot of advanced customers actually do this. All of this is covered in quite nice detail and as part of the official documentation of the tool. So I'm not going to go into further details to that. Now, why do we need validation capabilities in this context? Well, it's quite easy to explain why. It's because Enterprise Architect as an environment allows you to either activate or deactivate what we call this strict mode or strict connector syntax mode. And what we have found in our own practice is that a lot of users, a majority of users actually don't use this or disable this because it makes working with MDGs and the tool in general easier. However, the downside of that is that you can very easily end up creating diagrams or models which are not strictly compliant to the profiles of the MDGs because you may miss the application of certain stereotypes, or you end up applying the wrong one, or you make some other mistake, or simply because versions change and you continue working on your old project, that may also result in something like this. So what the validator can do is you can activate a built-in so-called validation library, this structural validation library that works with any MDG, so built-in, even encrypted ones, and of course all your own. It detects all the MDGs that are used in a particular project, and it runs a special set of validation rules, which actually are also illustrated here on this report on the right side, that check each of the relationships, whether their source and target are compliant in terms of applying stereotypes to what is encapsulated in the MDG definition. It also does what we call the view specification check, which basically checks whether the particular elements that you have put on a diagram are actually allowed to be present on that diagram, again, in terms of the MDG. And this is something that may seem simple at first glance, but if you are working with a complex domain like Archimate or UAF or others, this can become a very, very powerful and useful feature, because it's very easy to add what we call technical depth to your work and not even realize that you have done so. So here is a short live demo of how this feature works in practice. Now we are using BPMN as an example, and I will continue to use the BPMN example throughout this demonstration. We have activated the structural validation. It detects that the BPMN MDGT, aside from the standard profile, is used in this drawing, and it can detect errors like this. For example, this is one of the view specification issues, that this particular element actually lacks a proper stereotype that should be there, and otherwise it's not really allowed to be present on the diagram. Same thing can happen for connectors as well. So that's also a similar kind of mistake that is easy to make. And Finally, the connectors themselves can also be validated in terms of the source and target compliance. So whether that particular element in terms of typing or stereotype application is something that is allowed to be a target of a particular connector. Again, if you switch the strict connector syntax on, you cannot create such errors. So that is actually something that actively prohibits the user from doing this. But if you leave that off, it's very easy to do so. And then the validator can help you identify these mistakes and also fix them relatively easily. So let's move on to the more interesting and, of course, the most interesting aspect of this customization, which is what is sometimes called semantic validation. We actually did get a question the last time about this. Does the validator have capabilities to create my own semantic validation rules? Now, I found quite an interesting and nice article on the Sparx community site called How to Validate Your Enterprise Architect BPMN Models. And that also explains quite well what we usually mean by this. In our terminology, from the point of view of this model governance, this is actually both connected to the freedom from basic errors, but it also very easily leads to the methodology conformance, as we see later on. So just to, again, quote from this article, if you look at this example model here, maybe you notice that there are some subtle issues. For example, the final node does not have any incoming control flow edge, but has an outgoing control flow edge, which is obviously not correct. Final node should not have any outgoing control flow edge. And the reason why it is possible to create is because even if you do the structural validation, sometimes the MDGs are made in a way that allow, in terms of just typing checks for things like this to be created. Therefore, syntactically, this may be a valid model, but semantically, for obvious reasons, it's not. So that's why there is a need for doing semantic validation. Question is how to detect this as an error. Now, the original article goes on to explain how to write validation rules in OCL in an Eclipse-based environment outside of Enterprise Architect, and also do the validation itself outside of Enterprise Architect. With the IncQuery Validator, you don't need to do that at all. So the IncQuery Validator can do this inside Enterprise Architect. And how we do that is we create custom rules for the BPMN domain. Now, in contrast to the OCL, so the object constraint language, the validator uses a different specification language. It's also an open source language, actually, from the Eclipse world. It's called VQuel or Viatran query language. There is quite an extensive documentation available if you are interested. This is a query language. It's a declarative language, and the fundamental notion in this language is called a graph pattern. This graph pattern is an atomic or elementary unit of logic, which describes a set of conditions of how a particular part of the model should look like if we were to have a match of that particular pattern. And so for the IncQuery Validator, what we do is we use this language, this VQuel language, to create patterns that correspond to the erroneous, let's say, situations in the model that we want to report as either warnings or errors or whatever. So in this particular case, there are actually, let's say, two scenarios which I incorporated into my example to be reported as error locations. This start event has an incoming sequence flow. So we have a start event, and there is this control flow edge of type sequence flow coming from some element. We don't really care which one, but it goes into the start event. So this is something that I want to report as an error. And analogously, there's a counterpart to this, that end event has got an outgoing control flow edge. So this code snippet that you see on the screenshot on the left side is an actual screenshot from this Eclipse-based development environment. And these are essentially how we capture the specifications to these rules. So once we have something like this captured, then you can very easily deploy such a rule into enterprise architecture. Very soon I will show how. And once you have that deployed, you can run it, and it will actually behave exactly like all the other validation rules that come as part of the built-in libraries of the validator. So here you can see that we have drawn first the error in the wrong direction. It was detected as an error. Once the modeler goes on to fix it and they rerun the validation, then the error report will of course go away, and we can be sure that we have actually fixed the error. So this is the kind of behavior that is possible to do. Now let's see how we do this actually from a technical point of view, and this will be the real interesting part of the demo. Now for this demo, I will actually use a little bit more elaborate or more complex example than the one that was featured in this original article. So instead of just looking for, whether the start or endpoint has got some incoming or outgoing edge, I will show you what we can mean by methodology conform. So let's assume that we are a company that takes the business process modeling and even a little bit more seriously, and we want to make sure that we do not introduce, let's say, cyclicity into a business model in an accidental way. And what I may consider to be such a case of an accidental cycle is that there is a non-trivial, so longer than 2, cyclic sequence of message flows happening between activities that are assigned to different pools. If I have a cycle in activities that are in the same pool, I say that's fine. I just have a cyclic process. But if the cycle goes across several different activity pools, I want to make that visible as a warning, at least, so that my modeler is aware of this. So now this is really something that is a non-trivial, let's say, methodology conformance consideration. Let's see how we do that. Now, this will be a little bit more complex example, so I suggest to pay special attention here. So this is actually how the Eclipse-based environment works in its raw form. First of all, you can actually open an enterprise architect model inside this Eclipse environment as you would open any kind of Eclipse modeling framework model. We have a way of allowing these QAX or other kind of enterprise architect files to be opened directly in this way. And what you start out using is what we call this BPMN type library. This type library is basically the one that we supply for an MDG like BPMN2 that contains, let's say, helper queries or patterns to identify elements belonging to a certain type. So you don't need to deal with how to represent this stereotype application in this language. It comes as a built-in library that you can refer to. And once you have this, then you can start writing your own special custom query. This will be the cycle detection query in the VQuery language. Now, the VQuery language, of course, is a graph-oriented query language. So graph notions like reachability paths and transitive closures, which correspond to the computation of let's say, indirect relationships are very compact, let's say, capabilities of this language. So it's just enough to put this plus sign here in this line, and that will automatically tell the interpreter that I'm interested in the computation of this reachability, so this transitive closure notion. And here you can see a little bit, I will make this posit, how, if in terms of logic, we check for the fact that the activities which are part of this non-trivial cycle are belonging to different activity pools. We use some helper pattern for that, and we say that the pools should be different. So it's this easy and this compact to express such a rather complex notion that we are computing cycles and reachability paths along the model, and of course checking where in terms of activity pools each part of the elements of that cycle belong to. If this is something that looks complex to you, don't be afraid. As I said, there is a lot of documentation and examples available for this language. We can also help you with the training aspect. So once you get the hang of this and the logic of this, in my experience, it's quite easy to learn and use it in very, very powerful and intuitive ways. You can actually use this Eclipse-based environment to run these queries and these patterns and debug them without actually having to go into Enterprise Architect. So you can apply these query definitions against the model that has been loaded into Eclipse. So you can see what kind of results they yield. And here we can already see that there will actually be cycles in this particular model. So we should see some warnings being reported later on when we transition to Enterprise Architect. So how we put this into Enterprise Architect? The key to that is to create a special kind of configuration description file in a JSON language. You add some property values like it is highlighted this example here. This is also well documented as part of our environment. And once you are done with the JSON file, then the only thing that you need to do is to copy these files into a special location inside your installation of the validator. So it's just a file copy over operation, very simple to do, very quick to do. And once you have that done, then the validator will tell you that there was some change detected in the contents of the ruleset folder. And then this new ruleset that you just modified will automatically appear in the menu. You can run it as you would with any other built-in ruleset, and you will already see the results reported exactly in the same way as with the built-in libraries. It works exactly the same way. So it will compute the cycles. Indeed, there are cycles here. So we can fix the cycles by removing some of the message flow. So in this sequence, we already removed one message flow. There is still one cycle with 3 activities. So the modeler will go on in this demo, identify the problematic relationship somewhere. Of course, this is maybe a little bit tricky in some cases, but this I realize that's a problematic one. So I delete that. And then after I run the validation for one final time, I should realize that there are no cycles, no warnings anymore. So to sum up, it's quite easy actually in terms of the operation. Once you have this SDK in your environment, you follow the documentation, you use the samples that we provided, and then it's very easy to test live, either as part of the programming environment itself or in your deployment of the validator. So thanks again, and I will just hand over to Chris to say some final words as well.
No, thanks very much, Istvan. And while Istvan was talking about how simple it is to do the extensions and customizations, and with great documentation, of course, we are available to help out with that. One of our common missions is to help people figure out what modeling framework should they use, coming up with their own custom meta model, and then implementing that as an MDG technology. So helping out with implementing that customization in your inquiry modeling rules is another area that we can help out. And of course, one of the slippery slopes I see is that often our target community being engineers and architects, we're some really smart people. We can do anything, and it's not whether you can or can't do this stuff. I'm sure everybody is smart and capable enough to do it. It's really should you do it, because you guys, are the only people that can build the content that is, sufficient and suitable for your target requirements in your target organization. So, having a partner to help you out with that often makes a lot of sense. So this is part 4 of our webinar series on model quality and validation, moving from that to governance. And this is our last in the scheduled series. It's possible we might do some more, but talking about governance automation pipeline. So we're going to continue our discussion and get it grounded in model quality. So in our first 3 webinars, we talked about different dimensions of model quality, ones that were free from mistakes, missing meta properties, or things being accidentally connected to the wrong things, or using the wrong relationship, making sure that we're conformant to whatever methodology we're using for engineering and architecture, as well as our adherence to the modeling languages that we're using, whether that be SysML, Archimate, BPMN, or otherwise. So we kind of like to ground today's webinar around the overall governance in perhaps what might seem like a novel perspective, which is technical debt. And so I imagine most people on the call are familiar with the concept of technical debt, which really came out of software engineering. But ultimately it's about that there are side effects of deferring and postponing when we make necessary changes to things. So the further we postpone those, the larger our debt becomes. That debt, compounds with interest over years, so it becomes more and more expensive generally to address as we move forward. And then sometimes there are fines and penalties when it finally comes due to address those things. So, this emerged out of software engineering, but there's a case to be made, and particularly, from some great work that Ryan Noguchi did from aerospace, and he presented his perspective at the International Symposium in Dublin in July about talking about technical debt in the context of MBSE models. And so again, just a reminder that just like financial debt, debt's not inherently bad, but we want to make sure that we are understanding the kind of debt that we're incorporating into our portfolio, and understand the consequences and ramifications that we have, and we have a plan for it. So, for example, a lot of people consider going into debt for home ownership with a mortgage isn't necessarily a bad thing, although if you can't afford it, it's not good. As opposed to trying to live your lifestyle on credit cards is not considered really a good idea. So again, we're not about trying to eliminate it, but to manage it and make better decisions about it. And so it turns out from some of Ryan's work. The premise I think that I certainly can support in my work is that reworking models is just not the same as reworking software. In fact, one could make a claim that it's a little more difficult. Part of that is because it's often at a higher level of abstraction. It's about architectural perspectives. So it's more about types of things and concepts, and not actually related to the physical things that are being built. I mean, obviously trying to frame that. But again, tends to be more abstract and more broad in its scope. We're exposing internal implementation details, namely we're showing other modelers and downstream consumers, those internal implementation details, where normally in software, people just see what is on the outside. They don't ever get to go on to see all the fun stuff on the inside. It tends to be that, reworking models is less lends itself to doing it in bits and pieces. I mean, there are ways to kind of partition it and stage it, but it can be sometimes difficult to just make a single change here without really needing to understand how it's going to propagate and affect a whole bunch of other perspectives. Because models are multidimensional, semantical in nature, even if we are following our adopted method and our adopted standards, automated discovery is more difficult, of course. That is one of the key things that we think we can try to address with the automated model validation solution. And again, there also tends to be more prevalence of defects propagating throughout a model than perhaps might happen in software. And so the claim is that because of the consequences of poor models that are either poorly formed, poorly understood, poorly maintained, that managing technical risk is actually more riskier and more challenging for models than it is for software. And like I said, and it's great coincidence, obviously why we put this in here to kind of frame and really have a value proposition outside the engineering community, because of course, as engineers and architects, we do want to make sure that our models are free from mistakes, conform to our method, are compliant with our modeling standards. But there's a lot of people that really don't care about that. But if there's a way that you can describe how things are improving over time, or not improving over time, seeing the trend lines that, hey, we're getting better and better and we're cleaning up things, and it's basically going to have a positive impact, not just for current projects, but future projects and programs, is a great, wonderful thing. So from here, I think I'll hand it over to Istvan.
Thanks again, Chris. It was a very, very good intro. And of course, it caters very much to the topics that I will be talking about. So as Chris described, one of the key things to getting a grip on this technical debt issue is to automate certain aspects of the workflow, especially around the discovery of technical debt and quality-related issues, and of course, providing some means to handle the issues that we have discovered and get rid of them and address. So this is actually a set of features that are mostly highlighted in the team and enterprise tiers of the IncQuery Validators for Enterprise Architect. And this is exactly what I would like to show you today, how these features work. So in terms of, let's say, the overall layout of such a setup, of course, this automation is mostly or first and foremost relevant in a collaborative scenario where we have several different users on the authoring side who are working on, let's say, the same project or a set of related projects. And there may be other stakeholders in the picture as well, quality assurance experts or reviewers or integrators. Those kinds of stakeholders who are not necessarily in charge of generating the content into the model, but more consuming that either for further work downstream or from the point of view of a stakeholder like a quality assurance aspect or something similar. So in this scenario, the collaboration is typically organized using a platform such as a SQL server or a Git-based file version control system. This is what facilitates the synchronization of work that is originating from several collaborating parties. And in the team and enterprise tiers, our validator can be integrated in a straightforward way into such an infrastructure by attaching the validation, essentially in terms of functionality, directly to the collaboration platform. So not to the desktop or workstation environments of the authoring parties anymore, but running things on the server side. And the platform on which such solutions are nowadays built, also mostly originating from the software engineering domain, are so-called automation pipeline solutions or DevOps pipeline solutions. You may have heard this name as well. There is a lot of commercial offerings in this space, but also very popular open source alternative exists. I will be using one such open source platform for one of the demonstrations today. That's the Jenkins environment, but I will also be showing how such an automation pipeline can be organized on a software as a service platform, such as the one offered by GitHub. Okay, so let's take a step further and take a look at one of the demos in depth. The example that I will be using for this demonstration is actually directly related to the previous third part of the webinar. If some of you may have been there, you may remember that we have covered the methodology conformance side of this model governance concept, and specifically how to create custom-made validation rules for the BPMN domain. So this is exactly what will be the subject of the demonstration today. So first, in the first scenario, I am going to be focusing on one of the, I think, highest value-added benefits of this automation technology, which is essentially adding the capability of observing quality not just at a certain given point in time, as in terms of a snapshot of a project, but also how that quality evolves and changes trend-wise as we make progress along the project. So as we commit new revisions to the repository, are we fixing things? Are we adding new things? And this, of course, translates directly to this notion of the technical debt, because one of the main functionality of such a DevOps platform like Jenkins is to provide a dashboard capability to visualize technical debt at a high level in terms of KPIs, and also to see and visualize its evolution in terms of time, so how that changes in terms of trends. And this could be, of course, very useful to a reviewer or a stakeholder or an integrator, for example, from the point of view of observing how we hopefully reduce technical debt as a deadline for the release looms and gets closer in time. So let's take a look at a similar demonstration as last time. The first step, of course, is from the point of view of our quality assurance expert. They can just log into Jenkins and take a look at the dashboard without having to open Enterprise Architect whatsoever. So all of the violations and the indicators of how the technical debt situation looks like are immediately visible on such a dashboard. The validation report, as I have shown in previous editions of the webinar, is also directly available from such an environment as a so-called artifact that is, on the one hand, generated by the execution of these validation jobs and is also archived as part of a built-in facility of Jenkins. So the systems engineer can access such a report, and as you have seen in this demonstration, they can download, they can import the report directly into the environment without running the validator locally, and they can also, once they have fixed an issue, use the interaction with the version control system. For this example, we are relying on Lemon Tree by Lieber to provide an integrated experience with interacting with Git right inside the Enterprise Architect environment. And once this change has been pushed to the repository, then another execution of a validation was automatically triggered independently of what the systems engineer is doing. This report is generated based on the latest revision of the project that we are working on. And once the validation job finishes, then this dashboard will be also automatically updated. So in this particular case, our engineer has fixed an issue. Therefore, as you can see on the trend chart, the overall number of problems have decreased in between these revisions. So from the point of view of the quality assurance expert, we are on the good track in terms of reducing the overall technical debt of the project. Now, this is, of course, a simplified demonstration. So we intentionally kept the number of violations relatively small, and of course the whole project just a simple example. But I think you can clearly see what is the real power and the potential of a feature when applied to a real project, because using these facilities, it's really quick and easy to get a high-level overview on where we are in terms of our work, in terms of key quality measures and the technical debt overall, and what we need to do in order to reuse that. And from my personal point of view, the biggest value added capability of this system is that in order to use this, the only thing you really need from a quality assurance expert's point of view is a browser to go to the Jenkins dashboard, take a look at the reports. You don't need to open the project. You don't need to browse individual results or even look through a detailed report. Everything is to the point and simplified with maximum oversight as a priority. So we can take this one step even further to use the capabilities of the automated validation, not just for observation, looking at reports and trends, but also as a much more intrinsic part of the authoring process. So for this scenario, we will be taking advantage of the more advanced capabilities offered by Git, which is essentially the ability to work with not just a single, let's say, linear progression of revisions, but Git can handle parallel branches of work in progress at the same time. So people with Git can work on several aspects of the same project in parallel, as long as you have a facility to do merging operation. So when work that has been done in parallel by several different authors, like systems engineers, can be merged together in a meaningful way. Now, this is possible with Level 3, the product I mentioned before from Liber. But what we can, in terms of the validator, add to this landscape is a very important and very powerful additional capability, which is what we call the quality gate. And the quality gate, as you will see in the demonstration, is essentially the validator itself, but applied in a way that is run, also triggered automatically at certain points in the collaboration workflow, and that provides direct feedback from the quality-related KPIs into the facilitating platform of the collaboration itself in order to help making judgments, for example, when a so-called feature branch, so some parallel branch of work that has been started by someone is good enough in terms of quality to be merged into the mainline. And the reason why I say that this is a step further compared to the previous demonstration is because like this, quality and the automated tracking of quality becomes a main driver of the process itself. So you can organize your work in a way that whatever doesn't meet certain quality criteria will not be merged as long as that's the case. And this is why we use the term gate for this feature. Okay, may have sounded a little bit complex. Let's see it in action, how this looks like from the point of view of a systems engineer. So for this scenario, let's assume that our engineer takes a look at the release notes of the latest, let's say, version of the project that we've been working on, the 0.0, and I notice that there is actually an error in that release, which shouldn't happen. That's a problem that we don't want. So we want to make sure, in terms of technical depth, that all the releases that we do or the baselines are free of errors. So in terms of the collaboration platform, he will now create an issue assigned to himself, in this case, for the sake of simplicity, signaling that there is a problem that needs some fixing. Now, how do we go about addressing this problem? Now, in terms of the Git flow approach, what you do as a first place is that you create a so-called development branch. This is what is happening right now. And this development branch will be then the one in terms of the version control system on which we are going to carry out the work with the aim of getting rid of this error, so fixing the validation error. In order to do that, what we have to do is synchronize and then switch to this branch using the GitHub client. This is what just happened. And once that is done, we can start working as usual. We can open the file in question using Enterprise Architect. Again, the systems engineer will do the same as before. They will access the validation report directly from here instead of running the validator locally, because it saves a little bit of time. So you can import such an HTML file directly into the environment as we have seen before. So here you have the results already instantly without having to wait. And then you can double click and directly navigate to the location in the model, which is affected by this particular issue. This is a sysmod related governance rule. It says the actor administrator is not part of the system context. So we have actually a missing containment relationship. We add it back, hence the error will be fixed. Now we can do a commit and push operation. So this will essentially put this work, this fixed state of the model, back into the version control system as a new revision of the feature branch. This is again done using Lemon Tree as before. And once we are done with this, this is where the interesting, really interesting stuff will kick in, because this is the point in time where the automation platform will start doing interesting things as soon as we ask it to do so. And the way to ask the automation platform is to create a so-called pull request. So this is a collaboration artifact in terms of Git, which signals that, okay, my work is finished. I would like you to consider this for merging. Now, after the engineer has done so, as you can see, GitHub automation automatically triggers this model validation step. And the result of the model validation will be posted directly into this interface. So now you can see that the error is gone. There is no more error. We just have warnings. The model has passed the criteria. So we can actually go on and merge the branch. And once this operation has been done, we can see here that now the branch has been merged into the mainline. So what we can do now is we can create a new release. This will be this bug fix release, technically 0.2.1, derived from the 0.2 release. GitHub also has now facilities to generate the release notes based on what has changed so far. So it's automatically populated here really nicely. And once you publish a release, an additional automation step in terms of quality gate will kick in, which is what we call the release quality gate. Of course, in this case, as you can all already guess, it will yield pretty much the same results because we are validating the same thing again. But imagine if several people would have been merging their stuff before the release, then of course it would need to be checked all together to see where we are in terms of technical debt evolution. So this release quality gate works exactly in the same way as before. It takes a bit of time to run. I have accelerated this for the sake of this demo so that we don't have to wait that much. But at the end of the day, it will give exactly the same result, an integrated report directly into the Git system. That has a very detailed breakdown as to what's going on. You can download the full report, but also take a look at the high-level result. So this is essentially the way to integrate these capabilities on the GitHub platform, taking advantage of GitHub automation capabilities. And as you have seen, this way, all the capabilities of the validator can be taken to the maximum advantage without doing a lot of manual work because everything is essentially executed automatically by the collaboration platform itself. This is a very powerful way of using these things, and it's quite common practice in the software engineering world. Of course, in that case, not with model validation, but source code analysis and dependency analysis and security checks and things like that. The enterprise architect validator brings this idea and adapts it to the modeling ecosystem and taking advantage of the capabilities of these modern platforms. Thanks again for joining today. And of course, a special thanks to those of you who have been following us through the entire series of these 4 webinars. And now we are very happy to take any question you may have.